So I just want to, on behalf of the Clinton Climate Initiative and Partners in Project Green, I would like to welcome all of you to our first series of webinars that aims to promote an innovative green building technologies. I would like to thank J.T. McLean, coordinator of the Building Technologies Purchasing Alliance, for assisting us in holding these webinars. He is currently online, but is not on the webinar itself as he's having technical difficulties. So I'd just like to provide a brief background of Partners in Project Green. It's an initiative developed by the Greater Toronto Airports Authority and Toronto and Region Conservation with an aim to green businesses within the Toronto-Pearson area by delivering programming that helps businesses reduce energy and resource costs, uncover new business opportunities, and address everyday operational challenges in a green and cost-effective manner. More information on Partners in Project Green can be found on our website at www.partnersinprojectgreen.com, as well as our upcoming events. So I would just like to introduce you to Johan Larsson. He's the sales director from Climatewell. He's joining us from Sweden. A background as to his solar-powered air conditioning product.
Okay, thank you, Alexandra. So without further ado, we'll get started with the presentation. After the presentation, there will be a Q&A session, and then there are some rules to follow since we're many on the call, but I will get back to those rules once we get to the Q&A. Okay. So, well, solar-powered air conditioning is what we provide. It's a Swedish company and a Swedish technology, but we have distribution partners now in more than 15 countries on 5 continents. We have manufacturing in Spain and a bulk of installations in South Europe. As you can see to the on the image down left, a typical configuration consists of solar thermal collectors on the roof, generating hot water. This hot water is sent to the Climatewell units, and we can convert the hot water to chilled water. That chilled water is then distributed to the building through an air handling unit, fan coil units, chill beams, radiant media, whatever distribution system the building uses to provide air conditioning. This is applicable in any kind of building, ranging from small residential single-family homes to large commercial buildings. On a system level, it delivers air conditioning from the Climatewell units, heating, the hot water generated by the solar thermal collectors, domestic hot water heating, of course, and also pool heating, as we typically take the rejected heat, like any cooling device needs to reject heat. We convert this into a heat recovery circuit, and through this we can heat the swimming pool. It is applicable in all new construction, of course, and in most existing buildings. We were awarded the Ecomagination Challenge Award from General Electric end of the year, and also the Technology Pioneer 2007 from the World Economic Forum. 2 important milestones in Climatewell, or for Climatewell. To the right, you see an image of the product. The size, a bit over 7 feet high and 3.5 to 4 feet wide. The uniqueness of this technology is that we have an integrated energy storage, and this allows us to deliver air conditioning or cooling even during the night. This is, of course, based purely on renewable energy, solar, sun, and it leads to reduced carbon emission reductions since we replace or displace electrical consumption for the cooling process. It is profitable from day one, in the sense that you have your own energy generation system in your building from first day, delivering hot water, cold water, as we saw before. This system uses no harmful refrigerants. It's only based on water, which is another environmental benefit. It has no moving parts in the cooling core, There are no preventive maintenance schemes needed for a Climatewell system installation. So there you have another cost reduction benefit. We've designed this product to operate with conventional solar thermal collectors, meaning the exact same solar collectors as are today being used for heating of hot water. On this slide we see a typical schematic of an installation. We have a solar circuit, closed circuit, providing heat to the Climatewell units. As you can see here, we have 3 units in parallel. So for greater cooling power, you install more units in parallel. So it's entirely scalable. The hot water comes in to the Climatewell units at 90-95 degrees Celsius typically, and leaves at 80-85. Back again to the solar collector where it gets heated up to the 95 again. So we take energy from the solar collectors through a heat exchange there. On the right-hand side, to the upper right corner, you see a chiller. So with this, we want to demonstrate that a typical installation in a commercial building is climate working in series with a conventional system. You see the arrows here indicating how the Climatewell system delivers chilled water to a cooling coil, cooling down the air coming in here. The chiller kicks in and takes care of the rest if it is a cloudy day or if the cooling demand during this potential peak hour is more than what the Climatewell system can deliver. And the same goes for the heating. During winter, you have a backup heating coil delivering hot water from a backup boiler. And down to the center here, we have 3 cylinders showing how we preheat the hot water production in, for instance, a hospital, a hotel, or even in a residential application. As I mentioned before, we were awarded the Eco-Imagination Challenge Award last year. And in the early days of the development of this technology back in 2005, we got a prize from the Fraunhofer Institute. It's a German research institute, and this was very important for us back then to prove the validity of the technology. We have been awarded a number of different awards. I'm not going to go into detail about the different awards here, but it's of course an important message for such a new concept as solar cooling. In the following slides, I will show a couple of reference installations, reference projects, starting with a project in Toronto, in Mississauga. This is the Shouldice Hospital, the hernia clinic. It's a project that we are executing together with our Canadian partner GEMCO, Glenbarra Energy Management Company, based also in Toronto. It consists of 10 Climatewell units and 450 square meter of solar thermal collectors. Collectors on the roof, Climatewell units in the equipment room, and we deliver heating to the building in winter, cooling in summer of course, and year-round domestic hot water heating. And the distribution system here is air ducts. Another important reference installation for us, this building in Dubai was granted the Platinum lead by the US Green Building Council. Again, same principle, solar thermal collectors on the roof, 6 Climatewell units in this case in the equipment room, and it delivers air conditioning year-round, because in this climate air conditioning is needed year-round. Another typical installation, a hotel. We have several hotel installations. In this specific case, the rejected heat is not used for preheating hot water, but heating the indoor swimming pool that you can see down to the right. This is located in south of Spain, this project. The next is a typical office building. Same story, solar collectors on the roof. As you can see here, these are flat plate collectors, so we operate both with evacuated tube collectors and flat plate collectors, depending on region and price performance, basically. 4 Climatewell units in this case. It's a 1,000 square meter size office building, and this is located in Madrid in Spain. This is a residential project, townhouse development, centralized solution, solar thermal collectors on the roof, providing hot water to the Climatewell units, and we have a 4-pipe system here so we can deliver cooling and heating at the same time. In a development like this, a north-facing home might require heating, while a south-facing home during the same day might require cooling. So it's a 4-pipe system. And we're also heating the communal swimming pool. Okay, that was it in terms of presentation, and I now want to move into the Q&A session. So please press that. In the top center you see an image of a man raising his hand. If you press that button, there will be a symbol right next to your name and the list under participants. I will then call out your name, and then please unmute the speaker on the phone. And I have a first question here from Anatoly Naumov. Please go ahead. Anatoly, yeah. Is this Anatoly?
Hi, my name is John Pisani from TD.
Okay. Please shoot.
Maybe Anatoly, did you want to maybe write your question in the chat section, as we can't hear you right now? Then I will read out your question. He's just typing it right now. So Anatoly's question is, what's the business case for cooling in Ontario?
Well, in summer, most commercial buildings do need air conditioning. Although right now in winter, of course, heating is demanded. But even as far north as where I'm based right now in Stockholm, in Sweden, where it's -20 outside right now, we do need cooling in summer. So the business case is that wintertime we provide heating, summertime air conditioning, and year-round tap water heating for hotel/hospital applications. Is that an answer to your question, Anatoly?
And he's asking for the numbers.
Okay, so for specific numbers in terms of benefits, I would refer to our local partner, Glenbarra, based in Toronto. And after this session, I will be more than glad to provide you with contact information. It can also be found on our webpage at www.climatewell.com. And under partners, you can find contact information to our local partner.
Okay. He actually knows your partner, and he says thank you.
Okay, thank you.
Mm-hmm. So I noticed Jersanen has a question, and he raised his hand first.
Yep.
Yes, and so he's on the phone.
I'm from the city of Mississauga. We currently have a solar thermal domestic water preheating system installed at one of our community centers. I was wondering what's the feasibility of incorporating the Climatewell onto this existing system. These are evacuated tube units.
If it's an evacuated tube installation, I would say it sounds like very feasible. A site visit would, of course, be needed, and again, I would refer to our to Glenbarra in this case to have a look at it. If you already have the solar collectors installed, it's a fairly easy task to add the Climatewell unit to get the air conditioning in summer.
One more question. I was wondering, what is the typical payback with a a brand new installation?
It varies very much depending on the energy needs of the system. In your case, since you already have the solar collector installation in place, I would imagine it to be on the lower side. But throughout North America, we see paybacks ranging from 2-3 years up to 15 years. So it's very difficult to give a generic answer to that.
Okay. Thank you.
Thank you.
Also, it was Jonathan Segesi at that will be emailed out. A copy of this webinar will be emailed, and it will be to the gentleman that your partner here in Toronto, Johan. We can email that out as well. Is there anything else you're looking for, Jonathan? Anything in specific?
Other than a swimming pool.
If not, you can always email me back. And
Oh, great.
yes. So I'm sorry. I couldn't hear you. I think I had interrupted you. I'm sorry.
On your name or something, and then you...
Yes. So I will forward the contact details to Climatewell's partner here in Toronto. David Hunt, can you tell me how long it would take?
Yes, so again, the answer is that we see it depending very much from application to application and how much energy demand you have throughout the year. Again, anywhere between 3 and 15 years is
Other than pools.
Pardon?
What other loads are used to reject the low-grade heat?
Sorry, I couldn't hear that question.
Yeah,
Could you
what other
repeat?
loads I think I caught? Is there something? Could you write that down in the webinar? We can't quite hear you.
Low-grade heat.
Full sentence.
Okay, now I see your question here, Tim.
So the
The
question
swimming, yeah, as we said, or we preheat the domestic hot water. And if you cannot do any of the two, it's basically just rejecting the heat. You can use wet cooling tower. You can use geothermal boreholes with the advantage, of course, that heat can be somewhat, again, used in winter. But if you don't have a swimming pool or hot water production, it's unfortunately just have to reject it and get rid of the heat.
And so the question was, other than swimming pools, what other loads are used to reject the low-grade heat?
Right. So wet cooling tower, geothermal, dry cooler, depending on the climate.
Great. And Victor, I believe, is typing up a question currently. His question is, I understand how solar heating works, but can you explain how the cooling works with this system?
Absolutely. It's based on the absorption principle, but we've taken it one step further. So we've divided the absorption process into a batch process. What we, in an essence, do is that by applying heat, we force water to boil off from a salt solution, leaving salt crystals, solid salt, in what we call the reactor, and the vapor, because of the pressure difference, moves to what we call a condenser. And no pumping is needed for this process. It's just because of pressure differences. So that's the charging step. Now we've separated water from salt, and if we remove the heat source that forced water to leave the salt, we now have a pressure difference going the other way. because of physical laws that solid crystals, solid salt crystals have a lower partial vapor pressure than water. So when we remove the heat, the process will now be reversed. The water is now going back to the salt, so we get an evaporative condition in the container with the water, and this is the evaporation that we use for cooling. This side of the unit needs energy to make the water go into vapor again, because it wants to go into vapor because it wants to equalize the pressure differences. And all this happens in vacuum, so already at low temperatures water will start boiling. So we get the temperature from the air-conditioned circuit coming in at, say, 15 degrees Celsius. The system takes energy from that circuit through a heat exchanger and delivers 10 degrees back to the building. So that's the cooling process. So now water goes into vapor, goes back to the salt and meets the salt again, and here we get a condensation. And this is the rejected heat that we can use to heat the swimming pool or preheat domestic hot water. So each product comes with two identical units on the inside, which you don't see. So we can receive solar energy and charge one battery, so on, at the same time as we're delivering air conditioning by discharging the already charged unit. Inside the unit there's a batch process, but on the outside, from a black box perspective, we're charging and discharging the internal batteries at the same time. Was that clear enough?
Just typing right now.
A much more general detailed explanation can of course be done by our partners to the interested parties here. It's difficult to explain the actual technology without being able to show it with demonstration devices that we have.
Quite a few people with questions, and we're just waiting for them to type them out. So in response to your question, Johan, yes, it sounds similar to a Japanese absorption chiller system I read about using.
Right. It's similar in the sense that it's based on the absorption technology. And the Japanese absorption chiller was probably Yasaki. The big difference here is that we want to crystallize. We want the salt solution to go in solid salt crystals. And this is our modus operandi. And this leads to the benefit that we can operate with a fluctuating heat source, such as the sun. So if a cloud comes and the temperature goes down, that doesn't matter. It will impact the amount of kilowatt hours of cooling delivered, but no fancy control system is needed. So it's a much more robust system for solar applications.
Great. Tim has another question. If the input temperature are 90 and 85 out, what would typical temperatures be on the load side?
The physical limit is 0 degrees because we work with water and we run the risk of the media to freeze if we go lower than that. But to get a good efficiency of a system, typically it's recommended to connect Climatewell to an air handling unit where you can deliver 15 degrees Celsius and get 10 degrees back. We have installations where we deliver 20, where we deliver 7 degrees, so it depends from application to application. There is no fixed number here, but the higher the number, relatively speaking, the higher the efficiency.
Okay, great. So John has another question. So are there any other current installations that can be seen in?
Not yet. The Shouldice Hospital is the first project. It's actually the first in North America. But you're welcome to visit us in Europe or Dubai, Australia, or India, and if you want to see other or more installations.
Okay, and then David has another good question. How long has the Ontario Hospital installation been in operation?
It's under installation right now, and commissioning is planned for March. And we can get back to you on more specific dates when it would be suitable to visit.
Great. Are there any other questions? Victor is typing something, so. And if anyone is able to talk on the phone, you can just unmute. So Tim is asking, have you used horizontal GSHP loops for heat rejection?
We have not. We have boreholes, so vertical geothermal heat rejection, yes, but not horizontal yet.
Okay. Victor was typing up something else. Is there a way to estimate the size of the solar collectors needed? Something like M2 per cooling ton per heating MBH.
Yes, roughly 10 square meters per ton of cooling. That's a rule of thumb, ballpark figure.
Are there any other questions, maybe? Yes, there's one falling. And what about heating?
Right. Well, the heating is Climatewell is modular, so that we need 30 square meter per 3 tons. And when it comes to heating, each square meter added will provide you more heating. So it's just a linear relationship there.
Are there any other questions? Any final remarks you want to add, or?
No,
No?
other than
Okay.
thank you for attending.
Yes.
And please, through Alexandra, you can contact us directly. Go to our webpage or Glenn Barra Energy Management System.
Yes, I will definitely forward all that information over to everyone. And I just want to thank all of the participants for joining. We're very excited to launch these series of webinars, and our next one is scheduled for Thursday, March 17th at the same time from 1 Standard Time. So again, if you have any questions, you can email me. I believe you guys have my email address. And yes, that'd be great. Have a great afternoon. And thank you again. Bye.
Thank you.
Johan?
Yes, I'm still here.
Great. Thank you so much. Thank you. That was great. Did you want to maybe stop recording the webinar?
Yes, I'm stopping now. Record this meeting is being recorded.